And now let's talk about symmetry. The first type of symmetry let's talk about is y-axis symmetry. Means if you were to cut your picture down along the y-axis, you have the same picture on both sides. And notice on this first one, you do have the same picture on both sides of the y-axis. So that is why we call that y-axis symmetry. Now what we find out is if you actually want to test this by hand, the y-axis symmetry, how you're going to test is you're going to plug in a negative x wherever there's an x into your equation. If it stays the same, it does have y-axis symmetry. So to test for y-axis symmetry, you're going to plug in a negative x for all your x's, and the hope is that the function will stay the same. So then does the function stay the same? So does it stay the same? If it does, then absolutely it will have y-axis symmetry. If it does not stay the same, then it will not have y-axis symmetry. Let's try talking about the next type of symmetry that's kind of the natural jump, which is the x-axis symmetry. So the x-axis symmetry, which we see in actually the left or the rightmost picture, is very similar. It means that if you cut it along the x-axis, you'll have the same picture on the top and the bottom. So cutting it along the x-axis gives you the same picture on both sides. That's what x-axis symmetry means. However, what if you don't have a picture and you want to test x-axis symmetry? Well, then we're going to do something similar. We're going to test by plugging in a negative y this time for wherever there's a normal y. Then your question will be the same. Then does the function stay the same? Does the function stay the same? If it does, then it will have x-axis symmetry. If it doesn't, it won't. Okay. So, when you're testing y-axis symmetry, you're actually plugging in negative x for x. When you're actually testing x-axis symmetry, you're doing the reverse. You're plugging in a negative y for y. So, what are you doing when you're doing origin symmetry? Well, origin symmetry is kind of a combo. You're doing both the x-axis symmetry and the y-axis symmetry, which in terms of a graph means that the graph can be rotated by 180 degrees. It means both the x's and the y values switch. So it means that the entire graph can rotate by 180 degrees. That's what the origin symmetry means. Well, how do we test that? Well, we're going to test by doing both the x-axis symmetry and the y-axis symmetry at the same time, which means we're going to plug in two things. We're going to plug in negative x for all your x's and a negative y for all your y's. And again, the question is, then does your function stay the same? If the function does stay the same, then it will have origin symmetry. If it doesn't, then it doesn't have origin symmetry. So again, the question is, does the function stay the same? What's frustrating is you can't just test one of these, one of these work and be done. You have to test all three because it is possible to have a combination of these where you have not just one, not just two, but possibly all three types of symmetry. And there's no way to know without testing unless you have some kind of picture to test or an equation to kind of test out with. So let's take a look at a couple examples, and we'll start out with pictures first. So in A, what we notice is if we cut it along, let's see, just the x-axis, the pictures are not the same above and below. So there is no x-axis symmetry. If we cut it along the y-axis, we don't get the same pictures on the left and right. So again, there is no y-axis symmetry. However, if we do rotate the graph by 180 degrees, what was above will flip below, and whatever was below will flip above. You do end up with the same exact picture if you flip it 180 degrees. That's what we're looking for if we're looking for origins. So this one does have origin symmetry only. So on my math lab, this problem would be a check, or check all that apply. You would leave the x-axis blank, the y-axis blank, but you would check the origin box because it does have origin symmetry. If you do flip it by 180 degrees, the graph is exactly the same. Let's take a look at B. B, if we cut along the x-axis, notice we do have the same picture on the top and the bottom. So this does have x-axis symmetry. You have to keep going, though. You can't assume that's all that there is. Cut it along the y-axis. You don't have the same picture on both sides. What would happen if you rotate this graph by 180 degrees? It would not be the same picture. You would end up with kind of the reverse picture. If you shifted it by 180 degrees, it doesn't help you. It's not the same picture. So it only has x-axis symmetry. Let's take a look at C. And C, if we cut it along the x-axis, we do have the same picture on the top and the bottom. If we cut it along the y-axis, we do have the same picture on the left and right. So it does have y-axis symmetry along with the x-axis symmetry. And notice, if we turn the circle by 180 degrees, it's going to still be the same circle if we turn it by 180 degrees. So it will also have origin symmetry. This circle, not all circles, but this circle has all three types of symmetry because it's got a center at the origin, which means no matter what, no matter how many times I turn or cut this circle, it's always going to be the same on both sides of wherever you're cutting or turning it or anything like that. Let's take a look at D.